And welcome. This is Web 3242. Okay, great way to start, huh? We're going to take a look at Intro to Authentication. And so there are several approaches to authenticating clients against an API. And today we will learn a very common and simple approach that relies on two things called sessions on the one hand, and then cookies on the other. Okay. Along the way, we will discuss storing passwords safely into the database, because one always has to assume that the database gets stolen. Always. We have to assume, yes, we have to assume the database of our application gets stolen. That's bad enough if all of our business data is in there. But what's truly, truly bad is if the attacker can use the information stored on the database to log into our users' accounts and maybe our users' other accounts besides the one on our own app, because people tend to use the same password across services. So all of that, lots of fun. And this is the repo we will be using for today's project. And today is a big demo, so there are lots to do. So we'll try to keep a roadmap going on here at all times. Okay, so you see basically at a very high level what it is we're doing. Okay, so step one, at the end of the day, we are building a bunch of endpoints. That's all. So we will be building login, register, and log out. And besides those, another endpoint exists, a random endpoint to get users from the API. Okay, so once we are done building the auth flow, we will make it so that only auth users can hit the user's endpoint. So this will be kind of secure. Okay, but in order to test those 4 endpoints, we have to put them in Postman. We will make a collection in Postman, and that'll make our testing or manual testing a lot more efficient. All right, so everybody pop Postman open and get going, creating a collection. All right, here's my own Postman. And if you here on the left-hand side, that folder says collections. Okay, you can use the plus sign, and I'm going to create a new collection. We can just immediately close this tab that comes to be. We don't need it. We have that new collection going on there on the left, and we are going to rename it. So it's called auth. Okay, so I'll give you a second to get that collection going. And well, if you are having trouble with collections, at the end of the day, we will build 4 requests. So as long as you don't close the tabs, you can just reuse the different tabs. Log in, log out, register. Users, you can switch between the tabs. I find it more convenient if all the requests are saved into a collection. So the first endpoint is, and I came this to be with a plus sign there, make it a post and have it be http:// localhost 5000 /API /auth /register. Okay. I will drop this on the questions thread, which I will create straight on the on my post this morning, right? Question. There's our first endpoint. Allow me to apologize for the annoying, I'll ping the channel just to make sure no one zoned out and is not here with us. Okay. Cool. Now, every post request should have a body. Okay, in our case, it'll be a body of raw JSON. Okay, and the body will be simple enough. All it'll have is username of foo and password of, it's going to be a string. Okay. Although this string reads like a number, it's going to be 1, 2, 3, 4. The reason is because this is the password I use for all of my services. All of them. Okay. Except, of course, when 8 numbers are required, then I'll do, you know. Is it okay if I share this online? Okay, so as soon as you're done with that little piece of payload, which I'll paste there on the Slack channel, this request is complete, although of course it doesn't work. All right, could not send, so there's nothing listening on this port on my computer. All right, so that's the error I get. I'm going to save as register inside of auth. Okay. And again, if you are not fluent at this point with collections, just create several tabs, one per request, and you're golden. Okay. So login is going to look super similar to register. Basically, all that's going to change is this parameter there. I mean, this piece of the path. Okay. So I'm just going to duplicate this tab, and let's do login instead at the end of the URL. Same body, same everything. Okay, and save it as login inside auth. Okay. Now, I'm going to copy the URL, but I'm not going to duplicate this particular endpoint because logout is actually a GET request. So we will build it from scratch. So GET request on localhost 5000 /API/auth/logout. We do not need to supply anything to the server. As soon as we register our interest in logging out, the server will simply forget everything about us. Okay. So save this as logout. And finally, there is a user's endpoint inside this API. So I believe taking out the auth segment, we can do /API/users. And this is also a GET. Of course, the application isn't started, but this should be working already, kind of. So we are just going to turn to we're going to save this thing also as get all users instead of yeah, let's just keep everything in there. Okay, and now we can very quickly test our endpoints, right? This repo here is nice and cloned and npm installed right there. Okay, says on the README we have npm install to do, which we did already, npm run migrate seed and server. Oh, okay. Okay, let's do that. npm run migrate. Oh, I made a typo. So npm run migrate, I have no idea what it does, but of course the package.json is the source of truth always. All right, so it seems like migrate basically calls connects and just migrates to the latest. That's what it does. So let's execute it. Hopefully it works. All right. One migration ran. Now, okay, npm run seed to populate the DB. Let's do that also. npm run seed. And that also seems to work. Unbelievable. Things are off to a great start. Seed, by the way, and always check the package.json. If the script is too big, this will point to a file somewhere in the project you can go and take a look at to see what it is that the script does, right? This one is super short. It just runs all our seeds. Okay. npm run server. npm run server. Okay. It's nice that I got the port number right. So we are running on localhost 5000. And as soon as you get the server up and running, we should go back to Postman and test the get all users endpoint. All right. Okay. A single user as of right now. Cool. Everybody doing all right? Give me a thumbs up. Let me know if I'm going too fast, too slow, too whatever. Okay. Okay, cool. So this is going great. This is going great. Step 1 is done. Step 2, stub out, login, logout, and register. This means create minimalistic endpoints and wire them and test them out just to get, the wiring out of the way. Okay. And this is how you proceed when building an application for real. If you want to build a React component, you just don't write 20,000 lines of React. You first stub it out, you put it in the app, you check that it renders. So it's kind of similar here. Okay. So in order to stub out these endpoints, we are going to need a router for them. Right? So we're going to create a new router called the auth router. This router is going to funnel all the requests that start with API/auth, right? And authentication and registering of new users, all of that will be handled inside that router. Okay. Now, inside of API, we don't have a folder to keep auth-related stuff. So let's fix that. Within API, make a new folder, call it auth. All right. It doesn't actually need a model of its own because auth is going to consume the user's model to find users, to write new users, etc. All right. But we do need a router for auth, and we do need a piece of middleware. So let's go ahead and do auth-middleware.js, all right, and auth-router.js, all right. And let's stub out all the pieces inside these two files, all right. So middleware is just going to contain a single function called restrict. So this is a piece of middleware we will wire on endpoints we wish to restrict. Okay, reg res next. This means if there's any endpoint like users, an endpoint we wish to protect and refuse access to non-registered, non-authed users, right? So this is the user's endpoint we wish to protect. The protection will be done through this restrict middleware, all right? But we're not going to implement anything. We're just stubbing things out, all right? So let's console.log something like restrict middleware wired. And of course, what?
Export it.
Yes. All right. There's just one, but there could be more down the line. So let's just expose an object with restrict in it. However, I'm still not happy on how we left things in restrict. As a stub you want something that works without necessarily breaking the app. And this thing here, if we wire it to the user's endpoint, is going to break the app.
We need next.
Correct. So everybody put the invocation of next right in there. And now this restrict middleware, nice and wired, can be consumed inside the user's router. Okay, so shall we turn there next? Let's have both sides of the equation on the screen. The middleware on the left and the user's router on the right. Okay, and let's do const restricted. Oh gosh. Require. I believe we have to go up one level because this is outside of the user's folder, and then down auth, and then down auth middleware. Okay. If I'm making any typos or errors, I'm counting on you to save my bacon. Now, where do we put this restricted middleware, in your opinion? Any theories as to where to use this thing within the file?
Guess we'll
It
just
says, say again?
in the get after the slash and in between.
Yes, that is correct. This is a surgical piece of middleware. We want to wire to specific endpoints, right? I mean, we could have done something like router.use restricted. This too would have worked just fine, but it would have applied the restriction to each and every endpoint in the router, okay? So depending on what you want, that might be fine. I like your idea of just applying it surgically to the endpoint. Now, of course, with, oh, the app is crashed, actually, so we do have a problem. Router.get requires a callback function. Okay, so something is off.
I think you have the restrict with the ED and the other one doesn't have ED.
Yes. How would we have caught it using the tooling? Anyone knows? So you know how in order to check the paths, you hover, you click a special key near the spacebar until it turns into a hand? All right. But you can do similar thing with the word, with the thing you pull in, and I'm hovering over restricted. On the Mac, it's the command key. On Windows, it would be another key. Okay, so I'm hovering over restricted, and it doesn't change into a pointer. So this leads nowhere. All right. So I'll Control D or Command D and highlight all the instances of restricted, turn it to restrict, and see if the situation changes somewhat, right? So NodeMon is back to happy, and it's easy to make the hand appear. It's super small, but can you see that? Can make the hand appear, and you can even teleport yourself to where that function lives, right? Like a hyperlink. It is a hyperlink, right? Boom. super cool to verify the integrity of your imports because so many things can go wrong, okay? Now we could turn back to Postman, or we could use HTTP to hit /API/users. And there's the response right there. But most importantly, there's the console log on Nodemon. So this piece of middleware is correctly wired. And of course, we can also hit it with Postman. And there's our second console log of the day. Okay. So far, so good. This is the usual flow for fleshing out stuff in our projects. This is how we do it. This is how I do it. This is how it should be done, like in simple increments. It's just no good to just start writing a ton of code in there without bothering first to check the wiring, right? Otherwise, who knows what went wrong when things go wrong. Cool. All right, so we're done stubbing out auth middleware. Let's stub out the auth router. Okay, and it's right here. Nice and empty. And on the right-hand side, we will pull, where do we, server.js. Remember how you can do Command P or Control P or similar P to bring a search bar and just search for a file? And this is how your potential employer wants to see you searching for files when you are showing off your project in VS Code. It proves that you know your way around the editor, kind of, and that you know the way around the project. Okay. Cool. So, okay, let's get going with the router real quick. Const router equals require express dot router invoked. Before we forget, module.exports equals router. And then the router itself needs 3 endpoints, right? So let's do router.verb / and then async rec res next. Okay. And then we will console.log endpoint wired. All right. Now, of course, we have to, and you can make multiple cursors appear by make some room so the cursors can fit. All right, and then use the 2 buttons that are closest to the spacebar on the left, on the Mac at least, right? And you can have however many cursors there. Okay. Cool. So let's fix the paths, right? So the first path is register. The second one is login, and the third is logout. Let's fix the console logs. Oh, oh, come on. Endpoint login. And I'm going to stop for a second to give you time to catch up, all right? As soon as we are done fumbling around with our keyword. Oh gosh, what's wrong with me today? I got my COVID shot yesterday. That's my excuse. The verb, of course, this needs to be, the first 2 need to be post, and this one can settle for a get. Okay. Beautiful. Waiting for you all. And actually, you know what? Instead of console logs, let's just JSON back that text, res.json. I feel it'll make it easier for testing purposes. The auth router itself might use additional pieces of middleware, which we won't build today, but I can already think of things like check payload, right? For just making sure that register, the supplied username and password complies with the ever increasing and ever more aggravating conditions, etc., right? Questions, my friends? I can see the thread is empty. I can see you furiously typing out all of this stuff. Let me just drop it in the channel. Boom. Am I missing anything on these endpoints here? Let's wire that router back on server.js, server.use, and we set anything starting with /API/auth should be funneled into the auth router. And well, now something is really disturbing right now. Who knows what it is? Something about my tooling, something my tooling should have done but isn't doing, is real bad.
You can automatically import your auth router.
Well, actually, I disable auto imports because they get it wrong half the time. So I never use that. No, there's something else about the tooling, something that's missing that should have kicked in. Besides auto imports.
You should have a linting error.
Yes, exactly. So we failed to check whether linting was properly configured. This, of course, is optional, and you can see how NodeMon is angry. This, of course, is optional for the project. But if your npm is working fast for you, it's going super slow for me today. You can do npx eslint --init as always, right? And do the usual. Okay. All right. Okay, while eslint gets installed, let's actually make the import by hand. Const auth. Oh, there it is. Eslint is kicking in already. Look how it's complaining already about this variable coming from nowhere, right? So const auth router is require out of here. No, not out of here. Auth. Okay, so nothing super new, nothing super exciting in the demo yet. Okay, but this might be one of the most important steps of any project is stubbing things out. So they are testable. All right. So our tests in this case aren't console logs. They're responses to the client. So we're going to do the manual testing with Postman. So back to Postman, it is. Let's go ahead and hit register. Okay, endpoint register wired. Let's hit login. Okay. And let's hit log out. Okay, cool. Excellent. So if I were you, I would be making a commit at this point, right? So these little triumphs, always celebrate these triumphs with a little commit. All right. Questions so far? So when we come back from the break, we will continue where we left off, and we will do 3, which is basically flesh out for reals the register endpoint. And the register endpoint is going to require the bcrypt.js library, right? So this library basically takes our plaintext password and transforms it into a very random looking string. And this is what gets written to the database. All right. So the process is deterministic. From the same string always comes out the same hash. Okay. But the process cannot be reversed. We can't ever go back from the hash to the password. So if the DB ever gets stolen, and it gets stolen, all the attacker will have is a bunch of hashes which aren't any good to log into the system. Okay. So yeah, let's start a 5-minute timer and see you then. And we are back to Intro to Authentication, the day where we register, log in, and log out users using sessions and cookies. All right, so here's our attendance code if anyone missed it, 2176. And we have fleshed out, we have created a collection of endpoints in Postman so we can easily test the auth endpoints and the endpoint we intend to protect against non-authenticated access. We stubbed out the auth endpoints and we tested out our stubs, and we are about to register a new user, to create a new user in the database. But because storing passwords in plain text in the database is really, really bad, because it has to be assumed that the database leaks, and even if the database is stolen, well, there's ways to contain the damage. And one of them is not to store passwords in plain text. Okay. So cool. So bcrypt. Really quick. Don't let me do blah 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 for too long. Bcrypt contains inside a hashing algorithm, which is a function. This function can take any input, any kind of data, a lot of data, not a lot of data, sacred texts, all the information contained in the known universe, whatever you want to do, you can pass to this hashing algorithm, okay? And it gives back a string of fixed length, okay? So it doesn't matter how long the password or how big or small the input we feed the hashing function, the hash has a fixed length, right? So an attacker that steals the database and obtains a bunch of hashes cannot infer the length of the password from the hash, because the hash always has the same length. Okay. Now, for the same input, we always get the same output, so it is deterministic. There's no so the hash itself looks pretty random, but there's nothing random about the way it is generated for the same input, always the same hash. Okay, so in theory, if an attacker steals the database and sees a bunch of identical hashes, they could infer that the same password was used in all those cases. However, bcrypt, which contains other things besides the hashing algorithm, has things to defeat this. All right. But in general, hashing formulas output hashes of a fixed length. The length itself depends on the hashing algorithm used, and it's deterministic. Okay. So it can't be reversed. Okay. So there are some algorithms like MD5 that aren't cryptographically secure anymore. Not because it can't be reversed, no, but because someone came out with an artificial way of obtaining like a second piece of input that would produce the same hash, which is almost as good as being able to reverse it. But anyway, so these are the fundamental properties of hashing algorithms. Now, for hashing passwords, we also want the process to be slow, okay? Because one of the ways attackers try to defeat hashing is by pre-computing hashes. So get all the stupid things people use for their passwords. So the attacker makes an index of hashes for the most commonly used things, right? And then all they have to do is compare that index against the stolen database, and maybe they hit the jackpot and be like, oh, all right, so this hash corresponds to the password whatever, right? Now these tables, which these things which are called rainbow tables, right? So these indexes attackers build to make indexes of hashes out of dictionary words and common passwords, right? So this is defeated if the hashing process is very slow, because these rainbow tables, in order to be useful, typically have to be very big. So it takes time to build them. So if the hashing is really slow, that's one way to defeat them. And another way to defeat attackers is by including what's called a random salt to the password before hashing, right? So the idea is that the thing that it hashed is not just the plain text password on its own. That's not the only thing that gets hashed. Bcrypt comes up with a random piece of string, concatenated to the plain text password, and hashes that. All right. And because this little piece is random, two users using the same stupid password are going to result in a different hash, right? So slow and random salt are features of Bcrypt, whereas the things above apply to hashing in general, right? And we will go more over hashing tomorrow, okay? But for now, is this kind of enough for right now? Any questions? So MD5 sucks because it's not cryptographically secure anymore, and it's way too fast. So building rainbow tables with MD5 is a piece of cake because MD5 is so fast. It's impossible. You could have understood. I was going to say all of this, but okay. So, could someone take a snapshot of this thing so I can leave it and go back to my index and post it on the channel if you would be so kind? Thank you so much. All right, cool. Yeah, munch on that and ask me later more if you'd like. Okay, so back to here. Now we know we want bcrypt.js because it does a whole lot of good stuff to the plain text password, right? So let's pull it into the project and require it into the auth router. So npmi bcrypt.js. Okay, and then pull it in const bcrypt equals require bcrypt.js. All right, and this thing will be used inside register and later on inside login also, because the way we check a password is by recreating the hash. All right, so bcrypt will be used in both endpoints. Now for right here, we will do a try catch block because why not? And whatever error we will send to our error handling middleware, which I believe is nice and set up inside server.js. Okay. Now for the good stuff. And we're skipping important stuff, right? Like middlewares that would check that the password is there inside Rick body, that the username is there inside Rick body, that password is 8 characters long, et cetera, et cetera. We're skipping all of that, but all of that would be essential, right? So for right now, let's just pull username and password from rec body. Okay. We want to create a new user and save it into the database, but we better not save this object into the database as is, right? So let's do const hash, and the hash can be built with bcrypt using a formula called hash sync. All right. I mean, I guess we could use the async version too, right? It doesn't matter. So hash sync takes 2 arguments. Okay, so argument number 1, of course, is the plain text password we intend to hash, right? And the second argument is an integer, something in between, typically in between 4 and 16 or something like that. Let's do 8. So this is the number of rounds, number of rounds of hashing, And actually, the number is not 8, it's 2 to the 8th power, a huge number. So we are, and what is this 2 to the 8th rounds of hashing in order to produce the hash? Well, this is for the slowness part. Remember how we said in order to defeat attackers, bcrypt introduces the idea of slowness by hashing the hash, right? By hashing the hash and doing it all over again 2 to the 8th times or however many we wish. All right. So that makes the process of building a hash and checking a hash, well, slow. And the idea is that we test or production machine and make the hashing process as slow as our users will take it. All right. So for UI UX, for UX purposes, we can't have register take 10 seconds, right? That would be too much. But maybe it's fine if this takes 1 second or whatever. All right. So cool. So there's the hash. Let's just send them back to the client, res.json. And this is kind of like a console log of sorts. All right. Well, I guess we could just use a console log. It doesn't matter. Console.log hash. I just want to check that what we've done so far makes sense, right? And back to Postman, let's get our register example, or let's try and register foo with password 1234. Let's hit it. Ooh, and the server responds with the hash. All right. And we can take a closer look at the anatomy of a bcrypt hash later if we're doing okay with time. But the hash has several pieces separated by $signs, right? So the first piece is the kind of algorithm that was used. The second piece is the number of rounds of hashing, okay? That's not a secret. If the database gets stolen, it does the attacker no good to know that whatever rounds of hashing were used, but it is necessary that the hash itself include this information so that we can, check hashes in the future. But anyway, we can get back to that later. And NodeMod should also be logging in the bcrypt hash. So yeah, feeling pretty good about things. So I'm going to get rid of our little troubleshooting, and we better store the user to the database. Any questions before we take care of business? Okay, so let's make a, yeah, go ahead.
I'm saying, why is register going through hot if the person is just signing in for the first time? Is it because of the encryption that's why it's going through hot authentication?
Could you repeat the first part of the question? Why is what?
Why is register, endpoint register, why is it going through hot if the person is just signing in for the first time?
It's going through auth because we're already doing auth stuff, like generating a hash for them, right? And it's just, but I mean, it's up to you how you want to organize the endpoints. But I feel since register and login are closely related and they both use bcrypt, I feel comfy having everything live inside the auth router.
Okay, so what's now the difference between register and the user endpoint, user's endpoint?
Say again?
What's the difference between the register endpoint and the user's endpoint?
Oh, well, the user's endpoint is just an endpoint that lists all the users in the database, right? Whereas the register endpoint creates a new user in the users table with a hash in place of the password, right? So yeah, I mean,
Okay.
does that make sense?
All right. Yeah, I'm just thinking about the table structure. That's what's in my head, you know, but it's fine.
Of course.
Makes sense.
Okay, here's an idea. Let's talk about it at hand once all the endpoints are fleshed out. Let me know if you'd rather see this endpoint someplace else. Sounds fair?
Yeah, that's fine.
All right. Okay, so let's make a new user and write it into the database. So the new user is going to have username, obviously, and it's going to have password, except that the password is not the password coming in from the client, but it's actually the hash, right? So this is how we want the user stored inside the database. And now I believe there's a user model we can use. Const user is require. Go up and into users. Yeah, I mean, there's arguments in favor of having the register point to a function that lives inside. I don't know. I guess. Yeah. Okay, so there's the model. And the model, I can find out what's in the model by having VS Code tell me, or if VS Code doesn't seem to be telling me anything, we can do Control Spacebar and add new user. Okay. This, of course, is asynchronous, so we could maybe await it. Const created user equals await for that thing. And now and now let's just send it back to the client. res.json created user. All right. And we will also check the database to make super sure that the new user is actually being added to the database. All right. Okay, let's create the user Gabe with Gabe's usual password. Okay. Let's hit it, and well, the back and maybe we don't want to in a real system, maybe we wouldn't be sending back the hash, right? But let's just, for demonstration purposes, we can see how the user record in the users table comes with ID, username, and password, which is not plain text but hashed with bcrypt. Okay. Questions about register?
I have a quick question for
Go ahead.
line 2. Where did you get? I think I might have missed it. Where did you get the bcrypt from?
Oh, we installed it with npm. Let me find it in my history. Yeah, just add it to the project. Don't forget to do JS at the end there, because there is a bcrypt library on npm, I'm sure, right? So make sure to do bcrypt JS.
Okay, got it. Thank you.
And yeah, and we could kind of, and we always want to use a proven solid solution like bcrypt for things like this. More questions, my friends? Okay, so I believe we can shut down the server.js file. We don't need it anymore. And we can maybe make another user foo with password 1234, hit it, and there's the foo user with bcrypt hash, right? Now, popping the database open in SQLite Studio, and you don't have to do this. You can watch me do it if you'd like. It's always more fun. Fingers on keyboards, of course, right? So if you do pop it open, instead of users, you should see something interesting. Okay. Despite the fact that all of these users, well, actually, I can't remember the password that was used for admin. Gosh dang it. We can't log into the admin. Gabe and Foo are using the same plain text password 1234. However, bcrypt made sure very different hashes came out because bcrypt attaches a random piece of string to the password before the hashing, right? And that's another property of hashes. Besides fixed length and deterministic and can't be reversed, minimal changes to the input string causes wildly different hashes, right? So if as the input, one hashes, I don't know, Encyclopedia Britannica and obtains a hash out of the encyclopedia, and then one goes and changes one character of the encyclopedia and does the hashing again, the hash will be completely different. That's a really cool feature of hashing formulas. Okay, so this seems to be working. We seem to be able to register new users. Now, the next challenge, of course, is logging our users into the system. Okay. Now let's go back to our little roadmap. That, when we come back from the break, will be step 4 /log in, right? And we will learn ourselves a new library called express-session. Well, and also another library too, which is less important right now, which is called, I believe, connects session. It has a horrible name I never seem to be able to remember. Let me see. Connect session. I can't remember it. Either way, the important one is express session library. And this is going to help us create sessions on the server, right? Sessions are different from tokens. Remember when you did React on the third unit and sent tokens to the server to claim you are who you say you are, right? So it was kind of the client's responsibility to always add a token to the request. Sessions are a little bit different. Sessions are handled on the server. It's like a list of users who authenticated correctly with a server in the past, right? And these sessions leverage cookies, right? So, wow, a new library, sessions, cookies, lots of moving parts on the 4th point, a logging in point. So we better take a break and prepare ourselves.
Gabe, also, I think it's called Express Session, but then I remember something from last time since I flexed. We did something called Connect Session Connects.
Ah, that's the one. Connect session connects. Thank you.
It is a horrible name.
And we are back in business. We are successfully logging in users and hashing their passwords, and we kind of have an idea of why it would be terrible to store passwords in plain text. So much embarrassment has happened because of that. Super bad, okay? So bcrypt to the rescue, and now we are about to log users in. And the difficulty is that we can fairly easily build a login endpoint that simply checks the user password to see if it's a match, right? So that aspect is not hard, right? So to log in, there's several things going on. Login. Of course, the login comes with username and password, right? It's a post request by a client, okay? And the server is going to grab the password and check it using bcrypt. Of course, if the password doesn't match, right? So bcrypt can tell us whether on login the password matches the one that was used to make the original hash, right? If it doesn't match, obviously the client will be bounced. But even if the password matches, it's like, okay, so what does it mean to be authenticated? Authenticated. So what does it mean for us? It knows this. It means the server knows you are you. That's it. Okay. It has nothing to do with whatever rights you have or your role or anything like that. Authentication is all about the server knowing that you are you. Okay. However, HTTP is supposed to be a stateless protocol. Okay. In theory, one request by you and another request by you sometime later, the server has no way to tell these requests apart. So how's the server supposed to know that you actually are authenticated? Okay. The server has fatal amnesia. So it seems like we would have to supply username and password with every request. Otherwise, how could we be authenticated? Okay, so before we actually answer the question, let's flesh out login so that the password is at least checked. I think we can do that part fairly easily. So let's get back to our code, collapse the register endpoint, and start working on login. Okay. Try catch is the first stop, of course. And then, of course, on the try, we need to pull username and password like we did before. Const username password. And that, of course, comes from rec body. And same as with register, we are just not paying attention right now to other middlewares we should be using. But anyway, we can take a look at that later. First, let's pull the goodies from the request, and let's start thinking about how to deal with this thing. Okay, so for example, one check we could do that middleware should actually handle. But anyway, like, does username correspond to an actual user? So before checking passwords and things, like, why bother if username doesn't exist in the database, right? So the idea is that we fetch the user by its username, and maybe we have a model function that can help us do that. So we have find by filter. Okay, so okay. Oh, okay. Oh, okay. So it seems like this function is always going to return an array because we're not doing dot first at the end or anything like that, but it's going to allow us to find a user by whatever, right? So let's do const user, let's call it userdb maybe. Userdb is await for user dot get. Was it get? No, it was find by. What gives? There you go. There, find by. And in here, so the syntax used by this particular find by is the object syntax where we put the columns we're filtering by, right? In this case, username. So there's two possibilities here. UserDB comes back with something, or it comes back with nothing, depending on whether username already exists in the database, right? But always test your assumptions. So let's go ahead and res.json something like, I don't know, userdb. Let's just send it back. Let's just send it back, whatever it is, just to check our assumptions right now as for how find by works and all that. Okay. I'm going to move to Postman to test this out. Log in. Okay, so already nice and ready. Let's hit it. Okay. Oh, because we happened to have a foo username. The foo username came back inside an array as we expected. Let's do bar. Do we have a bar user in the database? And empty array. Oh, okay. Oh, all right. Okay. So actually, this UserDB is a very bad name. It is misleading because it's a list that can either be empty or not. Okay. So had we not stopped to do this little bit of manual testing, we would proceed with a bad variable name, which is sure to muddle our thinking and create bugs. Any questions so far? What would be a good name for UserDB instead of UserDB? Or maybe we could destructure something. I mean, since we know it's always going to be a list, we could destructure the user from the list, right? And now the two possibilities turn to the user actually existing, in which case we get the user not inside an array anymore. Or if we fetch something that doesn't exist, we get, well, nothing at all. Okay, so far so good. Now, this is how you proceed. Slowly checking, testing, okay? Now, two possibilities. If user else, well, the user doesn't exist, right? Invalid credentials, kind of similar. We could just call it our error handling middleware with a status of 401, right? And a message saying invalid credentials. No need to give attackers information as to, the username actually exists or not. Now, this is the truly happy path, right? So now is when we check the password with bcrypt. Although we could do it right there inside the test of the conditional, right? So we could say something like, hey, if user comes back and bcrypt says yes, right? So what functions do we have inside of bcrypt that can help us? Compare sync. Okay, so bcrypt has a compare sync method which takes the plain text password as the first argument, right? So we're comparing the plain text password against the hash from the database. And where is that? Well, that's inside user.password, right? Let me know if I'm going too fast? So take a look how we used bcrypt to hash the password, right? Similarly, the plaintext password was the first argument then, as it is now, except that, of course, when comparing, we need a hash to compare against, right? So basically, the comparing process is all about recreating the hash using this password and checking whether they're identical or not, okay? So if we fall through here, this means the credential's good. Credentials good, right? And we could res.json something like, you know, well, come back, user.username. Something like that.
Yeah, can I ask you a question? What was the, I mean, like, what's your thought process? Why would you do try catch over then? Is it just I mean, is there any reason why?
No, none whatsoever. You in this particular example, I feel like there's no advantage. Either way is fine because yeah.
Can you explain your line 25 again?
Okay. Yes. So we used the username that came in from the request, and then we used one of the model functions to pull the user from the database by that username. Okay. So if it actually exists and bcrypt says that the password and rec body is a match against the hash saved in the database for that particular user by that username, then we can assume the credentials supplied are good. Otherwise, we send the client packing. Okay, was that helpful, or are we the same?
That was helpful. Thank you.
Okay, excellent, excellent. More questions, my friends?
I have a question kind of on that same line. Does compare sync? Well, I guess like when you like user.password would have the salt in it.
Yes.
Right? And so like
well, the hash.
Or yeah, so like that still has like salt created with it.
Mm-hmm.
Right? And then when you check your password, is there like different salt? Because I thought that like because you're rehashing it, right? So does it not like look different even though it's the same password? You know
yes.
what I mean?
Yeah, of course. No, and that is absolutely right. So okay. So remember how bcrypt takes the plain text password, concatenates it against a totally random piece of string, and here's our hash, right? And you're saying, how can it verify? How can it recreate the hash reliably when it doesn't know what salt was used? Okay. However, the bcrypt hash in itself contains the salt used because it comes right there, and then after comes the actual hash, right? So this is the true anatomy of a bcrypt hash. So when we do compare sync, bcrypt is pulling the number of rounds from there and the salt from there, and then it can see if it can recreate that piece. Does that make sense? So both the number of rounds and the salt are appended to the hash itself, so it can be recreated to check credentials. Is that helpful, my friend?
Yeah, that makes sense. I guess just thinking in terms of security, I guess, I don't know.
No. I get it. I get it. You feel like, it's weird that, if we must assume that the database gets stolen, we must assume that these hashes leak, right? So how safe is it to broadcast the number of rounds that was used to create the hash and the salt that was used to create the hash, right?
Yeah, exactly.
Yeah, exactly, right? However, the way we defeat attacker is not by hiding those things. So the attacker gets us by creating rainbow tables. Okay, so what we don't need to obscure the hash used by each individual user. We just got to make sure that the hashing is slow and that a different salt is used for every user. The thing is, like, a rainbow table assumes no salt. If you have to start putting salts into the picture, even if you know what salts they are, if they're different for each user in the database, then you have to create number of rainbow tables multiplied by the number of salts that are used. So again, we're thwarting the attacker by making it unfeasible to construct rainbow tables. Does that make sense? It's a little bit of a mind bender.
Yeah, that makes a lot more sense. Thank you.
Awesome. And we can review some of this stuff tomorrow, okay?
Gabe, sorry.
Go
one more
ahead.
Question, if that's all right, with line 25. Sorry for background noise. So what's happening is it's hashing that password with compare sync, and it's reading the credentials from that user that password and then hashing it accordingly and then comparing them.
Okay, almost. So from user password, okay, what it's pulling is, yes, it's pulling. Oh gosh, where did we leave that piece? Okay, yes. So when compare sync, it's pulling the salt from this piece. This is the actual hash. This is the rounds, and this is the algorithm used, because bcrypt actually uses several, right? So bcrypt is pulling all of that information from the bcrypt hash stored in the database. In all those pieces is all that's required to check the password, right? With the algorithm, bcrypt can recreate the hash, it can use the correct number of rounds, and it can apply the correct salt and see if finally the correct hash is produced. So yes, it's basically recreating a hash. It's just that all these are a given now: the algorithm, the rounds, and the salt. Okay, is that helpful?
Yeah, definitely. Thank you.
Yeah, it's super clever. It's clever as hell. Anyway, even so, we're still kind of screwed because okay, the system identifies our credentials as valid, but how can we consider the user authed for the looking forward for the future, right? So let's quickly test the login endpoint. So bar, well, that didn't seem to do. Oh, 401 unauthorized. But why are we getting this HTML? I mean, it's correct. The unauthorized is correct, but else, are we not? Let's go back to, where's our error handling middleware? Where's our error handling middleware? We should have one inside server.js. Oh, we don't? What? How come? Maybe it was the user's router that had.
Yeah, there's one in user's router.
Oh gosh, dang it. So let's just copy and paste this thing real quick. Okay, so go to the user's router, grab the error handling middleware. You always need one, and maybe slap it there at the end of the auth router, and then something went wrong. Yeah, we don't need this custom. Yeah, let's just get rid of the custom error, right? So just plop that thing in there from user's router and take it for a drive again. Okay. Invalid credentials 401. Excellent, right? So let's pass valid credentials And okay, it identifies us and responds with this a sweet message, but still we're no closer to the solution. Yeah, sure, credentials good, but then what? All right, so there's still a little bit of time. So the theoretical underpinnings of what's going to happen come now in the form of another of our little drawings. Okay, so step one, cookies. The cookie mechanism. We use the cookie mechanism as the means of transport. Right? So it's general purpose. It's general purpose. Okay, so it's not used only for auth purposes. We can use it for whatever. So how does it work? Suppose we're a client right here, and we are fetching a page on cats.com. Okay, so we are grabbing index.html from cats.com. But of course, when cats.com loads, that triggers more requests, right? Like, for example, a cat.png, right? From catimages.com, right? I'm omitting the http:// but imagine fully qualified URLs. And this also gets an evil, tracking .jpeg, maybe, from tracking.com. Okay, so you know how loading a single page results in a cascade of network requests of all kinds, grabbing images, making, we have our Ajax application making Ajax requests, Axios requests for data, right? So maybe we're grabbing some JSON from api.cats.com. Okay, so all of these networks requests go to different servers, except maybe index.html and the JSON. It seems like both are actually coming from the same origin, except that we are using like a subdomain, but it's still cats.com for both of these network requests that happen. But all the others are requests to different servers on the internet, right? Now, when we make requests to servers, to any of these servers, they can respond, and among the headers used can come a header called set cookie. And inside this header, a little piece of information in the shape of a key value pair is stored, all right? And then on any subsequent request from the same client, the cookie foobar will be sent along for the ride automatically. So cookies are these things, these key value pairs of information servers can set on clients using the set cookie header. And then from then on any subsequent request to the same domain, that cookie gets automatically sent by the browser. So of course, catimages.com, they also want to track you a little bit, right? And when they respond with your image, they use the set cookie header with a response, and then a key value pair of bar equals baz, whatever. And then on every subsequent request from the browser to that same server, that cookie bar baz gets sent along for the ride, and on and on and on. Does that make sense? So when the server responds, and inside the response, there's a header with a set cookie, a foo bar maybe, a foo equals bar. On all subsequent requests to that same server on the same origin, cats.com, right? Whatever the request, there's a cookie header going along with the right with foobar. So what is foobar? This is the opportunity for the server to place a post-it note on the client, okay? Because the client, when the client comes knocking back, they're going to send that sticky note back. So theoretically, if we authenticate correctly with a server, the server could use set cookie to place some little piece of information it can use to identify us later as authenticated users, right? Okay, so here comes the foobar, and the server can be like, oh yes, I placed this particular cookie on such and so user who authenticated correctly with the system. Does that make sense? Questions about cookies. Cookies are not inherently auth or anything like that. Cookies are just, they've been around forever. They're used for many purposes, although tracking is the most obvious one. And they're broadly divided between first-party cookies. Can someone identify the first-party cookies in this drawing? There's first-party cookies and third-party cookies. And first-party cookies are the good cookies. First-party cookies are the cookies you want, right? The cookies that got placed by the server where you loaded index.html, right? So these are first-party cookies set by the server you were visiting with your client, whereas all others are third-party cookies set by servers different than the ones you were visiting, okay? Ooh, oh man, this is brutal. Questions? Otherwise, I'm gonna die here.
I just had a question. So, I mean, cookies, aren't they really for like analytical or like, I don't know, I mean, like just companies to collect data and like even, I don't know, possibly for themselves or to sell it or whatnot?
Yes, because that comes then under the umbrella of tracking. Because cookies are commonly used to identify you as your client as that same client that visited earlier. It doesn't mean they have any of your, they can gather some information about your system and your browser and so on, but they can't necessarily, they can't, but still they can identify you as a return visitor, right? So yeah, of course, they're used for all kinds of analytics and any tracking purposes, really.
I have a question. Cookies, I just want to make sure I got it right. It's basically you get authenticated and then it remembers it while you're on their site. So it's just you're an authenticated user.
Well, remembering a user as having authenticated is just one possible use of cookies, but cookies are just transport mechanism, right? Which involves two headers. The set cookie, which is used in the response from the server to place post-it notes of any kind on the client. And then when the client comes visiting with the request, the browser automatically puts a cookie header with the information. So cookies are just transport mechanisms. However, in this context of today, instead of in this bar is actually going to be a post-it note about a user that authenticated in the past, right? So when the user hits login endpoint, set cookie will be used and a foo will be set with what's called a session ID, which is a random ID the server can use to recognize you later. It's like a random string of some sort, right? So say you hit login with valid credentials, the set cookie header is used to place a foo of bar on your client. And bar, what is client? Client bar is a session ID the server will use to recognize you when you come calling back. So say you hit the /users Okay, because you have that cookie on your browser, a foo bar will be sent in that cookie header to the server, right? And the server is going to pull that bar and see if that string is a session ID it knows, right? And that is how it's going to work. Of course, all of this happens under the hood of the Express Session library. Oh gosh, we're way overdue for a break. Uh-oh. Okay. Okay, let's take a breather and start working with Express Session for real, right? See you in 5.
Gabe, I have a question. You want me to hold it, or do you mind if I ask
No,
it?
please do. I do need a break. I apologize.
Sure.
All right, we are back in business after our hopefully not too heavy introduction of cookies. Let's see if we can find our roadmap. Here's our roadmap. Back to our roadmap. We're still working on login, trying to figure out how to make the server remember the fact that we logged in, and we are going to use express session and connect session connects. So as we use express session, we will go back to our conversation of cookies, and I'll explain where each piece fits, okay? But give me just a few seconds to get express session nice and installed, and so should you. npm I express dash session. Okay. And as soon as that is done, we can pull it into the router, calling it, no, not the router, the server. Where's the server? Here's the server. Okay, cool. All right. There. Server.js const session equals require express session. Boom. Okay. Now, express session is going to be plugged as like any other piece of global middleware, right? So let's make some room in there. Maybe this line 11 is basically telling Express where our static assets live, like index.html and index.js and all those things, right? So underneath it, we're going to server.use session invoked, right? But session takes a rather large configuration object, and we will spend the next few minutes fleshing out all the options express session takes as for configuration, right? Now, the first piece of configuration ties back to our discussion of cookies. Most of the configuration ties back somehow to cookies, but please don't forget cookies are general purpose. They're not an auth thing necessarily. They're not an express session thing, okay, although they're used. Now, the first thing is the foo. How do you want to call the foo? Remember, the foo is the key of the key value pair that is stored inside the cookie. Okay, you can call that whatever, right? But let's call it foo, like we were doing in our drawings. Okay, so there's the key in which the session ID will be stored. Now, the second piece of configuration is a secret, and this should be a pretty long and random looking string, which of course should not be inside the code base, but inside the .env file, okay? Now, the purpose of the secret is the following. When you auth with a server, and the server uses setCookie to place a foobar inside a cookie in the browser, right? What it actually sets is like a session ID it can use to recognize you later, like, oh, I have a session ID of the looking like this, so this user must have authenticated in the past. The thing is that express session encrypts that thing for us, right? So we can't tell what the session ID actually is, right? And the secret is used for encryptation signing purposes. Now, the cookie takes more configuration. All right. So we will create a cookie key and specify max age, right? So if we don't set cookies to expire at some point, then browsers make the cookie super ephemeral. Like the cookie will basically be erased as soon as you close the tab, unless you specify a max age, which of course cannot be infinite, right? But I believe that is set in milliseconds. So we will do like 1 minute times, I guess 1 minute is fine, right? Just remember, this cookie expires rather quickly. More settings the cookie can take. Secure, let's set false. And if true, only works over encrypted right? So you know how most websites these days, thankfully, have the padlock there and use HTTPS instead of plain HTTP. So one security measure we can add to our application is making sure cookies, the cookie mechanism isn't even going to work unless the connection between the client and the server happens over HTTPS, right? This way you know the cookie is not going to be easy to steal or anything like that. However, because our development machine is not currently configured with HTTPS, we have to set this to false. The next key is HTTP only, which will also set to false. And what this means, if true, cookie not in document, right? So we can read, or JavaScript can read cookies inside document.cookie, okay? But we can prevent that by setting HTTP only to true. Okay? So that is it for the cookie. And there's a few other we must set, like for example, resave. We set resave to false. Consider this boilerplate required by some session stores. Right? So we can configure drivers and things to have the server remember who authenticated, even if the server restarts. Right? So there's many ways we can persist the authenticated users, but and for some of these schemes to work, you might have to tweak this resave value, but consider it boilerplate and don't worry about it. Save uninitialized. We're also going to set it to, well, actually, let's set it to true. So this means session not saved unless or not saved automatically. Let's phrase it like that. Okay. So we as developers, and we will do this inside the login endpoint. Inside the login endpoint, we will signal that the session needs to be saved, right? Otherwise, we don't want to remember, we don't want to place cookies on just any client hitting or API, all right? Cool. So let's leave this right here and back to our endpoint. All that we have to do to signal that we want to persist the session with the user is by changing a rec.session object, which came to be when we plugged when we did this little configuration. Now rec object includes a rec session, and we can write an authenticated user in there, right? So if we just do rec session user, add another property to the rec session user equals this user we we know is real and has provided valid credentials. So this is the magic line, signals session. So there's a tsunami of actions that happen because of this rec session user equals user. A cookie is set on client, and a session is stored for that user. Right? Both these things happen because we did this line here. Okay, that's how the express session library works. All right. So yeah, so let's take it for a drive. Let's take it for a drive. Let's come back to Postman and let's see if we can log in. Let's make sure we didn't break existing functionality. Let's log in a user that doesn't exist and it still responds with invalid credentials, so we didn't break that. Let's try logging in with a user that does exist, see if we can observe any difference here on Postman. So we send that. We're still getting the exact same silly message, but we're getting something else. Inside the cookies department, now we see one item there in the response, right? And there is the cookie. There's the cookie that the client is storing, right? So Postman is behaving like a browser would, right? If we take a look at the raw response headers, you will find a set cookie going on there. Okay, remember our little set cookie that happens on login with a foobar, and bar is a session ID that can be used to identify us later because the server's remembering all these session IDs. So there it is. There's foo equals, and this thing that looks really weird because yeah, it's express session is taking care of encrypting the session ID. So we have no idea what the session ID actually is. Okay. Now, I call login working. All right. So I'm going to move away from server.js and back to the auth middleware. How is the restrict going to make it so that only auth users can proceed with a request? Well, remember how we added rec session user here on this line? Well, all that we need to do inside restrict is something like, hey, if rec session, well, that's always going to be true because we use the express session library, right? But if rec session user, all right, if rec session user, that means, yeah, so we have a session, we have a session ID for this particular client, right? So the client sent us a valid cookie with a valid session ID, right? And the express session library will make the magic happen, right? So a lot of magic happens under the hood. So it's important that we have some understanding of cookies. Otherwise, of course, we are sent packing with a 401 maybe, and some message saying something like, you shall not pass. All right.
Is it bad practice if you have middleware that's, say it's that simple, should you have it in a different middleware? Does it not really matter? It's a small question.
In what other middleware? What do you mean? Besides restrict?
Yeah, I mean, like if you just have like restrict, I'm just saying, like for general purposes, wouldn't you just have it inside rather than like its own middleware?
No. If you ever ask yourself that question about anything, the correct answer is always yes. Let's make it a separate middleware. Okay. That's the node thing, and that's how endpoints are happier. Yeah, when in doubt, always separate. When in doubt, always separate. Otherwise, it would be very repetitive to have to remember inside each endpoint, we would have to check with a rec session user, right? So we can kind of make that go away by plugging restrict to an entire router if the entire router is restricted, right? So, and we did that inside the user's router. Where are you, user's router? Hello, user's router. So we plugged restrict here, but we could plug it to the entire route. And that saves us from that annoying check again and again and again. Okay. Now, how do we test this? Okay, well, we fetch users again, right? And we are getting, you shall not pass. Something went wrong inside the user's router, okay? Okay, so the problem is this request is not actually, well, it does include the cookie. What gives? What happened? Should have worked. Now that I think about it, the cookie is there.
Did the cookie like time out, or because it's still there, it's not time out?
Oh, exactly, because these cookies only last a minute. All right. So let's test it again. So everybody, come to log in, put valid credentials in there, just send it. Okay, there's the welcome back, and before the cookie actually expires, let's get all the users and pray that it works. Hit it. You're right. Okay, so the cookie mechanism is working. The postman is actually automatically, with every request to /API/users, it is sending the cookie automatically to the server with the foobar with the session ID, right? And the server is recognizing the cookie as holding a valid session ID, and is also recognizing the cookie as being not expired, right? So let's hit send again, and our cookie is still alive, right? But it'll die in the next few seconds. Okay. Now, this on localhost 5000, we actually have a little web page set up, right? So if you navigate to localhost 5000, we have a little HTML being served by our Express application. You can visualize the cookies inside the application tab, right? So if you open DevTools and take a look at application, you can find here on the left all the means of storage for the browser. Among them, cookies. At the end of the day, it's just a form of storage on the browser that is set by the server with a set cookie header, right? So cookies are compartmentalized by origin. Each origin is its own cookie jar, right? So the localhost 5000 hasn't set any cookies on the client yet, right? So let's try and log in as Gabe or whatever valid user you have on your own database. Let's hit login. Oh my goodness, why are we getting 2 cookies all of a sudden? Why are we getting 2 cookies? I'm not. Oh, there's foobar. Why is that foobar happening? I'm not sure. Maybe it's some garbage I left on the guided project. However, you can always refresh. You can always refresh your cookies hitting the circular arrow, and you can kill them all using the this X thing going on there. Where is it? How do I destroy my cookies? There, go away cookies, right? So get rid of all your cookies. Oh, not register, log in. Log in, delete, log in. All right, yeah, seems to be working now. And in some of these options which we set, like the max age translates to this expiration date. HTTP only is false. Secure is also false, right? So everything you want to know about the cookie is right here inside the application tab. Okay.
Ask you a question. Local storage is strictly for that person's local machine. That's all, right? I mean,
in machine and browser, right? So
and browser. Session
yes,
storage
exactly.
is like the one that's doing like, you know, I guess
session storage.
the database.
Session storage will go away when you close the browser, when you close the tab. Local storage will survive you closing the tab. Okay, And cookies will also survive closing the tab as long as a max age was set. Let's log in again. There's foo. All right. So this cookie will survive the closing of the tab. Actually, let's do it. I'm closing the tab. I'm reopening localhost 5000. HTTPS, no, it's HTTP. Popping open the application tab, and there's foo. Okay, still alive, about to expire, I'm sure, because we gave it such short life. All right. Cool. Questions, my friends?
Will the cookie like disappear after it expire?
It the browser will not. So actually, that's a great question. I'm not sure. Let's refresh. It should have yeah, there it is. It's gone. But more importantly than that, not just as importantly as that. The client will refuse to. The client shouldn't send it to the server if it's expired. So both those things, right? So the cookie disappears. The cookie is not sent back automatically. It doesn't use this automatic mechanism. Yeah, exactly. You're correct. All right. So let me show you log out, and because that is again handled with Express Session, and logging out is actually, yeah. Let's see if it gets rid of the cookie. But I believe all logout does, it invalidates the server. The session on the server, okay? So logging out is just going to make it that the session ID is going to be, the server is going to say, well, the server's maintaining an array of sessions, right? So imagine like an array. Each session is an object. Each object contains at least a session ID, right? And that is how the server recognizes later, right? So when the cookie sends the session ID, the server takes a look inside its sessions array and be like, oh, do I have a session object in there with this particular session ID? So logging out is going to destroy the session on the server, right? It's going to make it so this session ID sent in the cookie is not going to be any good anymore, but I don't believe it'll actually wipe it from the browser. But you can totally make that happen with Express. You can always kill a cookie by setting it to a date in the past. But anyway, yeah, let's just do it the easy way with simply Express Session. And basically say, hey, first, let's not do anything. So if rec session user, this means there's a session we need to kill. Otherwise, we can send back a message saying something like message, excuse me, do I know you, right? So if someone hits log out, but there is actually no rec session user, that is like, well, you are not even authenticated, so I'm not going to log you out. However, if there is rec session user, that means the session needs to be destroyed, and that can be done with a rec session object includes a destroy method. Okay. And once more, calling rec session destroy is going to make it so that this thing will be destroyed from the server. So the cookie is not going to be any good because the session doesn't exist anymore. Is that kind of clear? And destroy takes a callback with an error in first position, right? And this is how we did async in Node before promises. You would pass callbacks to be called later with the error object first. So if there's an error, we can handle it right? Like, for example, calling next with some silly message, right? Saying you cannot leave or something, right? So this shouldn't happen. This shouldn't happen. Else we can res.json a message saying goodbye. Right? And I'm feeling we're not going to use next. We're just going to res.json. Res.json. We don't want the 500 status code, I guess. Does this make sense? Kind of. It's more important to understand what it's kind of doing under the hood at a conceptual level, right? So think of sessions as arrays. Each object inside the array is a client that authenticated successfully. And the post-it note is a session ID, which was placed on the client on login. And the client can't help sending that session ID with every subsequent request using the cookie mechanism, right? So the session ID traveling in the cookie is compared against the sessions array to see if there is a session holding a session array, session ID, right? And of course, when we log out, what happens is the particular session we're logging out disappears from the sessions array, and then the cookie is no good anymore. Okay, back to Postman, we can test it out by logging in, right? Getting our little cookie there, checking that we can get all users without a problem, and then we should be able to log out, hopefully, and here's our goodbye. And now we cannot get users anymore, despite the fact that the cookie is still being sent, because the client doesn't know that the session has been invalidated in the server. Right? And we are, yeah. So let me sit here for questions now. I know this was pretty brutal. This used to be 2 lectures. Questions, my friends.
I had a question from earlier.
Yes.
I posted it in the chat. I've been getting an error, and I haven't been able to use Postman at all. So it's been.
What's the? Okay, so yeah, we can. Yeah, what kind of error?
It says illegal arguments.
Okay, so my friend, I have no idea. We'll have to troubleshoot it after lunch. If it persists. Okay, I'm sorry. It could be anything, right? So Postman, I don't know if the JSON is not properly formatted, it could be, I don't know, it could be anything, honestly. I'm sorry. We'll figure it out, I promise.
I don't mean to make this class harder, but we didn't mention Connect session store. Is there any chance we can go over that really quick?
Yes, and totally. So okay, so the deal, what Adam is talking about is the following. You know how now we can log in, right? Which allows us to get all users. Where's my payload? And but what happens if the server is restarted? If I restart the server, typing rs and nodemon, the session dies with a server restart. So there's and you can go to lunch at this point and just, I'll post the what you have to do in the channel, but for the benefit of the recording, I will just record it and keep moving on, right? So there are ways to persist these sessions to a database, right? And external libraries make it super easy, right? So with Express, there's a number of storage we can use, right? Or session stores, as they're called, right? And for one of them, we use npm install. What is it? Connect-session-connects, was it? So connect session connects is going to allow us to persist the session in the database, right? Because just storing it in memory like we're doing is great for development, but it's not great for production. So go ahead and install that fellow right there. And I'm also posting the name of the library on the Slack channel. Okay. Now, the purpose of this library is that we build a store, a session store. Okay. And a session store is built by requiring the connect session connects library, of course, connect session connects library, and passing it the session from our previous import, like so, right? Kind of funky, but there's a store we're going to use. And actually it's a constructor function that uses the new keyword. So I'm actually going to name it store capitalized, and you can name it whatever. All right. Now, inside our configuration, we're going to create a new key, and this key is of course going to be called store, right? This store key is going to come from a new store that we're going to build, okay? And this new store, of course, takes another rather large configuration object. Okay, so first, it needs to know where to find the DB config of the project, because this particular store is going to try and save your session to the database. So we need the database wrapper. So the database wrapper, we always call it DB, but in the connects documentation, you know how it's called connects, right? So have it be required, and now give it the path to DB config. So I think it's out of here and inside of database and inside of DB config. Okay. So that way the store can perform its own database operations because we're giving it what it needs, right? So next, table name is on what table you want to store the sessions, and we will use a sessions table, and if in even better, this needn't be inside our migrations. If this table doesn't exist, it'll be created for us. Next is session ID field name low caps, all of it. And this is like the name of the column which will hold our session IDs, because at the end of the day, we're just using the database to store session IDs. So let's just call it session ID for this column. And next, create table, low caps. All of these take low caps. Create table true, although I believe this is the default, but I'm adding it just in case. If this particular sessions table doesn't exist already, it should be created, right? And then clear interval. And I believe this one is camel case. And this is how often to flush dead sessions from the database. And again, you can pass a bunch of milliseconds, whatever. Okay, and there are more options Express session library takes and the connect session connects library takes, right? So on Slack, you have links to these npm packages, right? Let's make the session persist actually longer there. Okay. Ready to rock and roll? Now, okay, so here's the thing. We're going to log in. Then we're going to restart the server, and then we're going to fetch users to see if our session is still good. All right, and then we'll know whether this piece of business did any good. Okay. Okay, here we go. Back to Postman it is. Log in. Boom. Welcome back. Let's get all users. There they are. Now the moment of truth. We restart the server, typing rs instead of nodemon. And let's see if the users can still be fetched or whether our session died already, right? Hit it and Our session is still alive. Sweet. Okay. So now this sessions array, is stored in the database.
So
Questions?
you don't have to migrate in order to use that?
No, it's super magical, isn't it? You don't have to migrate. You don't have to make the session stable by name. But if we actually go back to the SQLite Studio and refresh our tables, check it out. There's our sessions table. Let's see, take a look at the data. There's our session going on there. Let's log in with another client. So we create a separate session, right? So let's do HTTP post localhost 5000 /API/auth. Oh gosh. What is it? Login and send username equals Gabe, password equals 1234 as a string, right? So it's the same credentials, it's the same human user, right? Welcome back, Gabe. But now check the database. If we refresh this table, check it out. Now there's 2 sessions going on because each session represents a separate client being a browser tab, so different browsers, different sessions. HTTP is a separate client, so separate session, right? And inside is the cookie information. More questions? Okay, I apologize for all the brutality. This afternoon, you have a project that basically has you redo guided project on your own, and you have tests and code grade to know how you're doing. So have fun with it and see you later.